ReflectorCAD is a paradigm-shifting design tool for designing segment reflectors. Segment reflectors, for example, are commonly used for automotive headlamps. The Exterior Lighting Test Module, ELTM for short, is an optional add-on for our Advanced Systems Analysis program, ASAP. ReflectorCAD, ASAP, and ELTM comprise the perfect set of software tools in terms of workflow for designing and analyzing a segmented reflector. Let's take a look at an example. ReflectorCAD was developed as a new design paradigm and packaged as a true graphical user interface to provide a long-needed illumination first-order design tool for segmented reflectors. ReflectorCAD allows you to graphically lay out the reflector segments, to compute very quickly the approximate intensity from individual segments or all of the segments in a source, and most importantly, to graphically adjust the radiometric output from each individual segment. ReflectorCAD then automatically will adjust and create that segment corresponding to that particular radiometric output. ReflectorCAD will also automatically fill in the spaces between segments with inter-segment fillers and allow you to 3D visualize the reflector, source, segment shadowing, and inter-segment fillers. The resulting reflector segmentation geometry, including inter-segment fillers, can be directly output to ASAP for further detailed engineering design and analysis, or to an IGES file for use with the CAD package. Another very important feature in ReflectorCAD is the ability to visualize a gradient anywhere within the luminous intensity output screen. This is a very important feature as gradients are becoming a more and more important requirement in the design of reflector systems. Let us now start a design from the ground up, but before we get to the actual design, let's explore the actual ReflectorCAD interface. On the left-hand side, we have an area where we'll be entering the actual segments of the reflector. On the right-hand side, we have the area which is going to be the luminous intensity output from each one of the individual segments as well as the reflector as a whole. In each area, you have the ability to set the grid spacings, for example, in terms of snaps per grid cell and the grid spacings for the segmented reflector. You also have the ability to set the same grid and snap settings in the output window. In addition to setting up the grid spacings for both the segmented reflector portion of the screen as well as the output, we can adjust some other parameters in the Output Properties box. In the Output Properties box, you will see you have the ability to adjust the vertical range of the luminous intensity output as well as the horizontal range of the luminous intensity output. Additionally, you will see an output scaling series of boxes. ReflectorCAD actually does not take into account the Fresnel reflections at the segmented surfaces. It also does not model the lens in the system, but you can put in bulk scaling factors in order to reduce the amount of flux transmitted from the reflector to the actual luminous intensity pattern. Additionally, you have the ability to change the output type. In our particular example, we're going to be looking at luminous intensity, but you could also set the output to be illuminance. Next, I'm going to start the ReflectorCAD workflow by clicking on the Setup button. Here I will set the system units. In this case, we're going to use millimeters. I will then set up my base reflector. The base reflector in this case is going to be a very simple parabola, which has a radius of curvature of 80 millimeters, and the focus of the parabola will be located at the global origin of my optical system. Additionally, I have the ability to enter some simple output aperturing of the reflector. In this case, it's going to have a racetrack shape with these following parameters. I will also have ReflectorCAD insert a hole of approximately 20 millimeters in diameter for which I can put in a bulb. ReflectorCAD has the ability to accept other types of surfaces as well. For example, you can import surfaces from ASAP, or you can translate IGES surfaces and use those base surfaces in ReflectorCAD. Next, I will set up the source or assign the source that I want to use for my particular design. Come up to the Source button, click on the Properties option, and come over and choose my source. ReflectorCAD has a variety of different sources that you can use for various automotive applications, including arc sources, head and fog lamp sources, LEDs, and tail and signal lamps. In our particular example, we're going to be designing a fog lamp. So I will click on the fog lamp section, and I will come over and I will grab an HB3 source. We can take a look at the model itself with the View Model button, and in this picture you can see that it is a very detailed example of an HB3 headlamp. Some important points to understand about ReflectorCAD. First of all, this model was actually created in Bro Research Organization's Advanced Systems Analysis program. It is a very sophisticated model which includes a variety of mechanical and optical mechanical properties, including an actual filament. ReflectorCAD actually does not use all of this information. It is going to primarily be using the ray information in its calculations. I will next position the source with respect to the global coordinate system in my reflector and click OK. At this point, I'm now ready to begin entering segments. So I will come up to my segment button and I will click on the segment and I'll enter in my first segment. ReflectorCAD creates the segment and draws the luminous intensity pattern corresponding to that particular segment. Now, in normal reflector designs, what I would end up doing is adding additional segments over here, each contributing to the luminous intensity pattern, and then I would have to come over and use some algorithm to change the prescription of these particular segments in order to get the desired output. As I mentioned previously, ReflectorCAD is an entirely new paradigm. In fact, what I will do is I will actually come over and operate on the luminous intensity pattern, changing that pattern to the desired shape that I want from that particular segment by dropping and dragging the various areas around the luminous intensity pattern, and ReflectorCAD will automatically update the shape of the segment in order to produce that particular luminous intensity pattern. Now, in the segmented area of the display screen, you will see a series of contour lines in the particular segment. What this indicates is whether this new segment is above or below the base surface that you've identified. We're ready to insert our next segment. I come up to my segment button, and I'll begin creating my new segment, and we'll see that the luminous intensity pattern from that particular segment with the source that I've defined now appears over in the output window. Once again, I will be able to take this luminous intensity segment and move it and reshape it to my desired output, and ReflectorCAD will automatically update that particular segment. Now, I can click outside of the segments which I have defined, and I see the sum total of the luminous intensity patterns from each of the individual segments. Or I can actually click on each individual segment itself and see the contribution from that. I have two segments defined. Now I'm ready to create a third segment. This is a luminous intensity pattern from the third segment. I'm ready to reposition this third segment to give the desired performance that I want from this segment. You will note in the design that I'm doing, I'm actually tilting or adjusting the luminous intensity patterns from the inner segments to correspond to the luminous intensity pattern on the outer portion of the beam. And the segments which are furthest away from the lamp actually correspond to the luminous intensity patterns at the center of the beam itself. This is a standard practice in designing segmented reflector systems. What we can see now is the sum total of the distribution of those three segments. The next thing I would like to do is take a look at how those segments actually appear with respect to the simple source that I've defined. You can see the three segments and the source down here. ReflectorCAD automatically puts in the inner segment fillers for me. I do have a small problem here that I have to correct in my design. First, this inner segment filler is much too large for production purposes. This inner segment filler over here actually has a direct path to the source, so light from the source can reflect off of or scatter off of that inner segment filler, causing a glare problem in the beam pattern. So what I really need to do is I need to shadow this inner segment filler by these other two segments. I can also look at that information numerically inside of ReflectorCAD. By highlighting a segment, such as my center segment here, then with the Shift and mouse keys, I can determine how far in front of or behind a particular segment is with respect to another segment. Green is good, red is not so good. Now what I can do is come into each one of these individual segments, go to their vertex properties, and actually shift them with respect to one another. I'll have ReflectorCAD redevelop all of the segments, and then I will look at these in my 3D viewer once again. And I still have a small problem with this inner segment filler here, which I'll have to correct. Now I have my segments shadowed by one another, so that direct radiation from the source will not hit the inner segment filler and cause a glare problem in the resulting beam distribution. Now, I could continue the design, and in doing so, put in each one of the other segments for this quadrant, as well as this quadrant in the lower right-hand corner. ReflectorCAD has an easier way of setting up these segments, however. I can come to my segment button and click on Mirror Existing Segments. I have the ability to mirror segments about the X and the Y axes. I will first mirror them about the Y axes, maintaining the same or mirroring the aim points of those particular segments. Next, I will come back to my segment button and mirror the existing elements about the X axes, but I don't want to mirror the aim points because I want the distribution pattern from those segments to end up in the lower portion of my output window. And now you can see the contribution from each individual segment and the total contribution from the reflector itself. It's always a good practice to check the reflector and the segment spacings with respect to each other to make sure there's not a problem with the inner segment fillers. And clearly down here I have a problem with these two segments. The inner segment filler is clearly visible or in direct path to the actual source itself, and that will produce a glare problem. I can come in and adjust each one of these segments if I want to, but what I will do in this case is I will delete both of them and create a single segment in their place. Once again, the exciting new paradigm with ReflectorCAD is the ability to move the luminous intensity pattern, dragging it and dropping it to the desired distribution that I want, with ReflectorCAD automatically updating the segment itself. In this case, there is a very small, if no, inner segment filler visible, and that's probably good enough for this point in my design cycle. I now have designed a segment reflector for a front fog lamp application in literally a matter of minutes. I now have the option of exporting this to either an IGES file or to ASAP for further analysis. Let's now open a file designed in ReflectorCAD. Keep in mind that ELTM can be used to analyze virtually any design that can be imported into ASAP. We click on the ELTM button and we'll open up a file, a predefined file, which has some of our fog lamp information in it. The exterior lighting test module screen is composed of several areas. First is an area to define your geometry. This geometry actually includes the source distribution and the reflector distribution. You have the ability to add sources, and the source we're using for this particular example is the HB3 source, which will look something like this. This is a very sophisticated source which contains the optical and mechanical geometry, including the filament structure and various source apodizations. In addition to defining or setting up your sources and your reflectors, you have the ability to choose from a wide variety of tests. In our particular example, we're going to be using the SAE front fog lamp test. But you also have the choice of various Federal Motor Vehicle Safety Standard tests, as well as European tests. The options window allows you to trace rays, and it also allows you to determine how you are analyzing the luminous intensity output from your simulation. In addition, you have the ability to set the actual plot window. When ELTM is doing its actual calculations, you will see the luminous intensity pattern displayed in this area, and in the lower portion of the screen, you will see the test point values and whether you have passed or failed. Once you have set up your system and your source, and you've told ELTM that you want to do the ray trace and the various analysis, you simply hit the Apply button, and ELTM and ASAP begin the simulation and calculation. We've created a source with approximately 1 million rays, and now what we're looking at is the actual reflector geometry and the source geometry. As you can see, it is a very complicated source with all the mechanical and optical properties assigned to that source. These sophisticated sources are required in order to do complicated designs and analyses of these types of reflector systems. I will now switch over to the ELTM window area, and we can see the results of our calculation. Indicated in the window is the basic luminous intensity pattern. You can drop and drag the cursor to look at various slices through the field of that luminous intensity pattern. In the test point area, you can actually click on the test points, and you can see those test points highlighted and whether you passed or failed. In this particular example, most of the test points have passed, with one test point that has failed. The test point that has failed is in the upper area of the luminous intensity pattern. This is not as troublesome as would first indicate, because in order to do a more sophisticated analysis, we would actually add in the shelving of the reflector as well as the outer lens, which are not included in this particular analysis. However, we've been able to analyze the performance of a segmented reflector and determine whether it has passed or failed the variety of test points for this particular application. And just to summarize what we've done, in a matter of minutes, we've constructed a segmented reflector, transferred that segmented reflector into ASAP, analyzed its performance, and have determined whether that particular design is going to pass or fail.